Hi, I'm MD Saidur Rahman. I'm an intern at the Spark Foundation. This is my task 7 stock market prediction using numerical and textual analysis. I'm using Apple stock price from 2018 to 2022, which I get it from Yahoo Finance, Y Finance, and using alongside the Indian news headline. I've imported the necessary libraries, pandas, numpy, matplotlib, and lstm for time series analysis. This is the short overview of how our data frame is, the head and tail version. Then I have done some checking if there is any null value. Uh, then I've done feature engineering at phase 2. So we need the features to uh, the significant features. We need to find out the significant features. So here, as the date is our main index, so we have to convert it to date and time mode. So the object the data type here is object, so it needs to be uh, converted to date and time. Then filtering needs to be done. Then we don't need all the columns. We only need these date, open, high, low, close, and volume columns only. Uh, so I did a filtering here. After that, I have done the index setting according to dates, then sorting according to ascending order. So this is our final stock up to phase 1. Then comes phase 2.2. Here the news headline data. We have to now process the news headline. So I have done I have checked for duplicates. If there is any duplicate news, I have dropped the versions. Then I have done a headline. Then I've done a published date. The published date, we don't need, we only need the published date in a date and time format. So I've done applied a lambda function so that we can make the numerical date to a date time object type, so that we can we have to I have to use the same object. I have to use the same data type in both cases. So I have to normalize it and make it to date and time. Then news headline info. Then I've done the filtering. After that, the grouping. Now we need to group the two things together. Now the published date and headline text. We only need these two. Then with the grouping according to date. This is our final news headline according to date, where the published date is a date and time object. After that, phase 2.3, where I combined the news and our stock price together so that we can do our main analysis here. This is the final information about the data. So we can see it here. According to the date time index, there are 7,717 entries. So now the stock, we don't need so much entries. We only need 1021, as other have null values. So now dropping the null values. After that, combining additional sentiments. Now now I have imported the sentiment analyzer here, the sentiment intensity analyzer from NLTK, so which I use to do a sentiment analysis among four different things. One is compound, then negative, neutral, and positive. For to do this, I had to go through a sentiment analyzer here. It will show me the sentiment values of each part. Here you can see that the positive is 0.08, negative 0.1, neutral 0.8. The majority is the main they mean to follow. So after that including the date, we got our features, 10 features. Then this is our final SVD. I saved the CSV file. Then I've done the indexing. Then the shape, we can see the shape is rows are 1021 and columns are 10. So there's another check. I did another check if there is a null value or not. After that, described how I can by describing a function, we can see that our total statistics of the whole data set here. You can see the maximum is 182 and the minimum is 35 for open, but we don't need open right now. We'll need only close here. Okay, this is the figure of our closed price according to dates from 2018 to 2021, 21st December of 2021. It's a upper curve. Okay, now now I have implemented the rolling function to calculate the mean for 7 days. So we need 7 days because of many things. Okay, then I've done the plot figure of close plot and our rolling plot together. It can see the average plotting of how is the closed function, our closed data are moving towards time. Then the phase 3 data pre-processing. Here I pre-process the data, calculated the data, and I need to use only 80% of data for training and 20% for testing. So which makes 816 for training data and 2205 for testing data. Then depending on each columns, and I started to capture the data for each column here individually. After that, I shifted to the next day. That close price shifted though. So here, as our stock price, we need to see the previous day and next day or current day value. So I introduced a close price shifted value, which is the immediate before value. The close price shifted and close price. Here you can see the date around the first date. The close price was here 43.1325 and the close price shifted to 998. The next day, for the close price was 43.135, but it shifted to here. So for each data we can see the close price and the shifted close price, which will help us for further analysis. Setting target variable, then I set a target variable close price shifted as our predicted variable, target variable, and the features should be close price, compound shifted, volume. These are our features. After that, scaling. The thing is, as we know that LSTM is very sensitive to time series data, so we need to scale our data. Otherwise it will become unstable. It might become unstable. So scaling our data set as min max using min max scaler. You can see here. After that, the data separation and training and testing has done here. Okay, then I've done the data modeling here. So that's a random seed. I have chosen a random seed of 2016, and I've used LSTM layers 100 and dropout of 0.1, and it's a 3 layer it's kind of 3 layers we can here add it. So using the activation function 10h, so this is the parameters, this the model's parameters summary. We can see here that our total parameters are around 201,000. After that I compiled the model using Adam optimizer, and I've calculated the mean square error for 50 epoch and batch size 8. So we can see the validation error is getting reduced, and after that the successful model training, we can have saved the model in JSON format here in Kaggle output. Then I've done a prediction performing. So for only the first five data, I've done a prediction. I've performed a prediction. Then after that, the time of model evaluation. So the trailing evaluating the training loss and testing loss, and I've done the model evaluation here. We can see they are very less, 0.0179 training loss, and testing loss is 0.2. After that the root mean squared, I calculated the root mean square, which is 109.43, and the root mean square error, which is around 109.43. And lastly, finally, the plotting the prediction against our hidden data. So in the final figure we can see that our predicted close price is the blue one, and the testing close price is this one, which is kind of does not fluctuate that much, but they are kind of similar. Here you can see the peaks are same, the slopes kind of are having the same pattern. I guess we can do more better by shifting the parameters, hyperparameters, then we can achieve a more accurate prediction. That's all from me. Thank you for watching.